Hello everyone, my name is Zhang Yuhong, and my professor is Guo Wenjun. Today, in my speaking topic, is about the development of the optical coherence tomography system for the trachea image. So that in my outlines, first, in introductions, I will tell you about respiratory disease and common diagnosis methods in the medicines. Second, I will tell you the OCT image of the respiratory tract and how to use the OCT for observing to the internal conditions of the trachea. Third is my experience about the sweat cell OCT, how to use the OCT to observe to the respiratory tract in my experience, and what problems the eye encounters. The last is about the conclusions in my future work. So in my first part, introductions, the respiratory disease and common diagnostic methods in the medicine. So what are the common diseases of the trachea? The first two diseases is the bronchitis and the inhalations of the toxic gases. In the two diseases, they have the inflamed and swelling, and the mucus is a bloodshot. We can see the CT image of it. The bronchitis and the inhalations of the toxic gases can cause significant redness and swelling and the burn in inner lining of the trachea. And then our introduction about the three diseases of it, the long-term contributions, and the tracheal technosis, and the tracheomalacia, the three diseases of it. And then we can see the long-term distribution image in the unders of it. Why we have this disease? Because an abnormal heterophy of the mucus due to the prolonged frictions between the tube and the lining of the airway. The second is caused by the abnormal growth of the cartilage and caused by the genetic factors of tumors. Unless a genetic disorder recognized by the softening of the relations of the walls of the airways and cause the airway to collapse easily. So what instruments do we rely on first? Trachea. In the projection image, in statics, we can use the chest X-ray. The dynamic, we use to the bronchoscopy. Second, in the cross-sections image, statics, we use the CT and NRI, and dynamic, we use the cine-CT and cine-NRI. And in addition, in the golden standards, we use to the bronchoscopies of it, so that we can see the four image we tell about the three instruments, the image of it. But in the whole of the system, they have a problem of it is about the contrast agents and X-ray radiations may cause the discomfort of a potential harm to the human's body. And the bronchoscopies insertions may cause a foreign body sensations. So that we need to find the less invasive and less damage and non-radiations without the contrast agents and the high resolution systems to have an image of it. So that's I will introduce the OCT image. So in my two parts, I will tell you about OCT image of the respiratory tract and how to use the OCTs for the observing in the internal conditions for the respiratory tract. So that in the OCT, we can see the 2D image on the left. In the trachea and the symphysis, we can see the different muscle there of it. Then when they got the image of it, they were turned to the polar image to easier to watch the trachea. And when they got the polar image, they can put into the 3D model soft. And they have the 3D model solved, so they can make doctors can cause cross complications between the CT bronchoscopy image and OCT image. In the future, we hope that expressions that OCT image alone can be used of a rapid of accurate and diagnosis. So that in my experience, I choose the OCT to see the trachea. So my OCT is a name is about Swepso OCTs. So how to use the OCT observed to respiratory chest in my experience and what pattern did I encounter is my 3 parts I will tell you. So in my Swepso OCT setup, we have a lasers and the laser will output light into the copper. The copper will to the light in the reference and the sample. And to that sample, we have the probe of it. So that we have a red light off of it. We can see it is a rotating of it, and we can to the whole trachea we can see of the scanning of it. And then when we got the reference signals and the sample signal go back to the circulators, and we put the signal in this copper. So the copper will get a coherence, and coherence will get a light signal into the balance detectors, so that the balance detectors get the electric signals to the DAQ card to the computers. The computers will have the image on it. So how SSOCT get the image? First, this is throw to this image. The throw outside, we use a tap to off of it. And when the probe is rotating, in the AI, we scan the sample like this way. And second, we use the that make the 2D image to the polar type. And last, also, we can have the dynamic light time image of it, so that OCT allows to observe the conditions of the respiratory tract. And then in order to observe the OCT image of dynamic bracings, I made the Cedic's airway phantom. The airway phantom is distinct coatings of a silicon with a polyvinyls and echoes as a disappearing mode. So that by the infecting in the in natural respiratory simulation, use the syrinx and the change in the tracheal diameters and contractions can be mixed. Meanwhile, adjust the probe depth alone for the real time and observing to a dynamic change at the different positions, so that it is hoped that the area of the trachea during human revelations can be quantified. And that's now facing the problems. The first, we can see the 2D image about the phantoms in the fingers of it. In the finger, we can see the layer about it of it, but in phantoms, we can see the known layer, the depth in this image. Why they have this problem of it? Because the silicon skill abilities to allow the light penetrations and hinders applications of the tissue's image. The second problem, we can see the dynamic of light-time image. We can see the light-time image is have the motions of it. Why it have these problems? Because inconsistent rotation speed of the probe in the shapes and the image accretions speed result in the image instability. So in my conclusion and the future work, first in my conclusions, OCT adjusts issues of the contrast agents and the ionizing radiations in the exposures, as well as a discomfort associated with the extensive contact with the trachea. Second, OCT improves image resolutions, and its microstructures layers image also improve the accuracy rates of the doctors in diagnosing a tracheal disease. In my future work, I will improve the image synchronization for real-time image acquisitions. The second, the material properties of the patterns result in the abstruse acoustic learnings. Last, I will create the 3D image of a simulation to watch the tracheal image. And this is of my reference about these speakings. And thank you for your listening.